Right, in this video, we're going to be looking at the Gordon growth model. More specifically, how do we get the formula of the Gordon growth model? So if you see the formula here, the D1 over RS minus G, or the D1 over R minus G, how do we get to this formula? What is the derivation behind that? If you're familiar with the Gordon growth model, you know that it is used to determine the price of a stock by adding all the future discounted dividend payments. So it takes all the future dividends, discounts them, brings it back to today, and adds it up. So that's a form of a dividend discount model. What is unique about the Gordon growth model is that it assumes that there is a constant growth rate till perpetuity. So there is a perpetual growth rate, or the growth rate goes on till infinity, and it is constant. So it's also called the stable growth model. That means you have a stable growth rate for a long period of time. It is part of the dividend discount model family. So the price of a share using the Gordon growth model, if you have constant growth rate from now till infinity, then the value of the share just reduces to the next dividend divided by the required rate of return on the stock minus the constant growth rate. Right, so dividend D1 is the expected dividend per share 1 period from now, because when you're holding a stock, the price today is dependent on how much the value of the dividends will be in the next period. So it depends on all the future dividends. So this is one method of valuing a stock using its future dividends. Right, here's an example. So if the next dividend is going to be $5, if we know the required rate of return is 10% and the expected growth rate, the perpetual growth rate is 6%, that means from now till infinity, or now for a very long period of time, we expect the growth rate to be equal to 6%. Then you can just plug in these three numbers to get our value of the share. So based on this information, the value of this stock is worth $125 per share. There are certain assumptions. So the assumptions are that we know what the constant growth rate is. So the growth rate is known. Usually this is subjective, and there is a lot of, there might be differences in opinion about how much this growth rate is. But for this model to work, the growth rate has to be known. And the fact that we know that the firms will have a constant growth rate forever or for a long period of time, right? Very, very long period of time. And that the firm pays dividend, right? So this works for firms that pay dividends, since we are discounting based on that. All right, so the price of a bond. So let's look at the derivation. So if you recall, for a dividend discount model, the price of a bond is the sum of all the future dividends, of not just the future dividends, but the future discounted dividends. So if you have a required rate of return based on the riskiness of the stock, if the company is riskier, then you're going to have a higher required rate of return. If it's less risky, then you can have a lower rate of return. So based on the riskiness of the company, we are going to discount these dividends, right? So the riskiness or the uncertainty surrounding these dividend payments. If there is greater uncertainty whether you're going to receive these dividend payments or not, there's a lot of fluctuation, then you can use a higher required rate of return. Well, anyway, so this is the formula for a dividend discount model. We have all the future dividends from 1 year from now, or the next dividend. So D1 till infinity, or very, very long period of time. And then each of them are discounted, sum it back, that's the price of the stock. If you have a constant growth rate, then we can rewrite these dividends. So D2 is going to be D1 times 1 plus this constant growth rate. D3 will be D2 times another 1 plus growth rate, or D1 times 1 plus growth rate squared. So we can replace, if you have a constant growth rate from now till infinity, then we can replace all these dividends, D2, D3, D4 with D1 times 1 plus G. Right, so this changes the equation that the price of the stock today is now a function of D1, the growth rate, and the required rate of return. you can see that some of these terms are the same. For each of these, we have one D1 in all of them. We have 1 plus R, at least 1 plus R in each of these. So let's factor those out. So if we factor this out, D1 over 1 plus R, then for the first term, we're just left with 1. In the second one, there is 1D1, we took that out. We have 1, but we still have the 1 plus G remaining for the numerator. So the numerator is just 1 plus G. For the denominator, we took out 1 plus R, and we have 1 plus R remaining. Okay. For the third term, we took out a D1. That leaves us with 1 plus G, and we took out 1 plus R, so leaves us with 2 1 plus R. So 1 plus R squared. Right? And then you can do the same for the fourth term. So this reduces to an equation with D1 1 plus R factored out. And in the parentheses, you have 1 and several different 1 plus G over 1 plus R's. So let's rewrite some of these things, since you can see like a theme emerging, and it becomes quite cumbersome to just writing this large term every time. So let's rewrite this. Let's call this D1 over 1 plus R. Let's call this alpha. And then this 1 plus G over 1 plus R, let's call that rho. Right? So this notation over here looks like a P, so that's rho. So this way we don't have to write this whole term every time. So this entire thing becomes alpha. So this is alpha, this is 1, and then this whole thing is just rho. If rho is 1 plus G over 1 plus R, if you have 1 plus G squared over 1 plus R squared, then this entire thing is rho squared. And then the third or the fourth term here, this is rho cube. The next one would be rho to the power 4, and so on, right? So this goes on till infinity. All right, so that's the price of a stock today with a constant growth rate. So if you could sort of take a snapshot in your memory of this line, if you go to the next slide, you'll see that's where we start. So this is what the price of a stock looks like. It's alpha times 1 plus rho squared plus rho cube, and then it goes on with rho to the power 4, 5, and so on. Right? So this is the price of a stock. This is what it looks like with a constant growth rate. Let's take out the parentheses. So if we take this out, this will leave us with alpha plus alpha times rho plus alpha times rho squared. So you see it's alpha times 1, so that's alpha times rho, that's alpha times rho squared, and so on. Actually, never mind. Let's put back the parentheses. But this time, let's put the parentheses from the second term. So if we have alpha and we take alpha and rho starting from the second term, if we take that, factor that out, that leaves us, for this first term, it just leaves us with 1 because we have factored out alpha rho. We have factored out 1 alpha, 1 rho, so it leaves us with 1 rho. Factored out alpha, 1 rho, leaving us with rho squared. And then the next term would leave us with rho cube. Okay. Let's rewrite this. Let's bring the rho to the other side of its multiplication, so it doesn't matter. 1 times 2 times 3 will give you 6. 1 times 3 times 2 will also give you 6. So the order for multiplication does not matter, so we'll just bring the rho to the other side. Take a closer look at this term. So we have alpha plus alpha times 1 plus rho squared plus rho cube, and it goes on till infinity. Recall that snapshot that you took in your memory. Just to help you jog that, price of a stock is equal to alpha plus 1 plus rho squared plus rho cube. Looks like we have the same term over here. So what we'll do is we're going to replace this entire thing with price of the stock at time period 0. So price of the stock at time period 0 is equal to alpha plus this entire thing is also price at the time period 0. And then we have this rho. See, the rho was not part of this equation. So price of the stock at time period 0 times rho. Right. It looks a little strange, but this is happening because we have this equation going to infinity. If it was for a finite, a simplification like this wouldn't have been possible. So now let's just do some algebra to find out what is the price of the stock in terms of alpha and rho. So bringing price 0 times price at time period 0 times rho to the other side of the equation will just leave us with, so bringing this to the other side just leaves us with alpha. Factoring out price at time period 0 leaves us with 1 minus rho equal to alpha. Now we can bring the 1 minus rho to the other side. So price at time period 0 becomes alpha times 1 minus rho. And now let's plug in the values for alpha and rho. If you recall, that alpha is d1 over 1 plus r. And rho is 1 plus g over 1 plus r. Do a little bit more algebra. Let's find out if we take 1 minus 1 plus g over 1 plus r, what is that equal to? So if we do that, this is what our denominator looks like. It is 1 plus r minus 1 plus g over 1 plus r. Now you can see that there are certain things that you can do to simplify this. So 1 plus r, you have that in your numerator. We have this in our denominator. Both are in the denominator, so we can cancel those out. So the 1 plus r and 1 plus r gets canceled out. This is 1 plus r minus 1 plus g. So this would become 1 plus r minus 1 minus g. So you have a positive 1 and you have a negative 1. Those two would cancel out, leaving you with r minus g. So canceling out the 1 plus r leaves us with just d1 in the numerator. And then in the denominator, again, this 1 plus r is canceled out. Positive 1, negative 1 canceled out, leaving us with r minus g. And that's how you get your dividend, your Gordon growth model or your constant growth model, where the price of the stock today just reduces to d1 over r minus g, provided that we have a constant growth rate from now till infinity. Right. I hope you found this helpful. If you want to work out some of the algebra, I would highly encourage you to do that.